Hi, my name is Andres Sandoval. I'm a lecturer at the University of Bath, and my main research interests are comparisons of education systems using international large-scale assessments and with a focus on inequalities and civic education. This here is Gerardo, he's my son, and he's joining me for this presentation. No, that's not true. Today I'm going to talk to you about international large-scale assessments in education. I'm going to put up some slides and I'm going to speak over them. And this is, of course, to replace or in replacement for the lecture that I was supposed to do today at the university, but due to the weather conditions, we are going to do it on video. I hope you like it, you are interested in it, and if you have any questions, please don't hesitate to contact me. Bye. The purpose of the lecture of this video is to discuss the impact that international large-scale assessments in education have had on policy, research, and practice. It is also the objective to describe the scope, the objectives, the methods, and the information produced through these assessments. In this session, we are going to talk mainly about TIMSS, PISA, and ICCS. I will come back to these acronyms in the next slides. Also, the objective is to discuss the main challenges and criticisms posed by different actors against international large-scale assessments, and finally discuss, hopefully, or review some proposals for solving these tensions. So let's get started. First, there are some general questions that originally I was going to ask you, but now I'm gonna review briefly for you. So this is the questions are: what are international large-scale assessments? What are they for? What are their main characteristics? And who uses this information? So what is an international large-scale assessment? Well, this is a test, to put it in simple words, to put it plainly. Let's suppose that we have a test of mathematics or language or science or civic education, any test. So let's suppose that we have the same test applied to a representative sample of students in different countries. So the same test to comparable groups of students in different countries. And then, because it's the same test, we can compare the answers, we can compare their scores, and we can see who's doing better. And then, in a second stage, after knowing who's doing better and who's not doing so good, the next question is why? Why are some countries doing better than others? In order to know that, these international large-scale assessments, apart from the test, they include a set of background questionnaires. They ask questions to students, to teachers, to principals, to parents, and they ask them about the education process of the children. So for example, to the children, to the students, they may ask questions such as how much time they dedicate to homework, how motivated they are to learn mathematics, what are their study strategies, how do they get along with their teachers or their peers, whether they are bullied or not, etc., etc., etc. And of course, some personal characteristics, the gender, the age, the socioeconomic status, etc. And to the parents, they ask them questions about their children, if they support them to do homework, if they have expectations for them to study further, etc. And to the teachers, they ask them about the relationship with the students, what are the teaching strategies, personal characteristics about the teachers, etc. And to the principals, they ask them questions about the school. How big is the school? What is the proportion of disadvantaged students? If they have all the infrastructure they need to run the school properly, if they have a library, how many books are in the library, if they have computers, if they have internet, etc., etc. And then they use all this information to try to know why some countries do better than others. What are the characteristics of the countries that do better in the test? what are the characteristics of the schools that do better in the test, what are the characteristics of the students that do better in the test. And with this information, comparing this information, they try to infer, they try to formulate public policies to help education systems to do a better job. So what are they for? I think I already answered these questions. They are to produce policies, to produce, identify practices, policies, characteristics of that are going to help to improve educational achievement across different countries. What are the main characteristics? Well, they are international. They happen in a number of countries at the same time. They are large-scale assessments because they are applied to representative samples of each country. So you have them at different grades or at different ages. But for example, if you are evaluating 4th grade in mathematics, you have to collect a sample in each country that will allow you to generalize your findings to the whole population of 4th grade students in that country. So we are talking about 150, 170 schools, 5,000 students, and around this number also of teachers. So they are large scale. There are lots of people is involved in collecting, designing, collecting, and analyzing this information. And they are, well, international large-scale assessments because they assess different areas of domains. And who uses this information? Who do you think uses this information? I don't know if you have or haven't heard about these studies like TIMSS or PIRLS or PISA. We're going to talk about them in a minute. I don't know if you have heard about them, but what I want to tell you is that there is lots of people involved in this assessment. This is, as I said, just to give you a sense of the size of the assessment, but also all the people who is involved in it, and to give you a sense of how many people is using this information. And then I'm showing you, this is for 2012. I just put in Google TIMSS 2012, and these are all the academic publications that were written in 2012 with only one of those studies. And as you can see, there are a lot. If you consider that for each of these publications you have a team of people working on them, then you will see that there is loads of people involved in them, in analyzing them, in studying them, in trying to find those characteristics that are going to be useful to improve education across different countries. We are going to. So what are some examples of these international large-scale assessments? Obviously you, or I think many of you may have heard about PISA, which is this international large-scale assessment from the OECD, but large-scale assessments are much more than that. In fact, the pioneers in international large-scale assessments is an institution called the International Association for the Evaluation of Educational Achievement. And they started with studies like TIMSS and PIRLS, and more recently ICCS. TIMSS stands for Trends in International Mathematics and Science Study. PIRLS is the Progress in International Reading Literacy Study, and the ICCS is the International Civic and Citizenship Education Study. The OECD, on the other hand, has this well-known PISA, which stands for Program for International Student Assessment, and they also have PIAC, which is the Program for International Assessment of Adult Competencies. And this PIAC is also known as the PISA for Adults, which is the main characteristic of this study is that it is not for children in school age, but for adults. And they also have other studies like TALIS, which is the Teaching and Learning International Survey, which is a study focused on teachers. UNESCO has also come into this arena, and they have different studies. The main characteristic of UNESCO studies is that they are focused on regions. They are not international or global. like in the case of the IEA or the OECD, they're focused on regions. So they support, for example, the TERCE, which is the third regional comparative and explanatory study, and SACMEC, which is the Southern and Eastern Africa Consortium for monitoring educational quality. And as you can see, well, it is not obvious by the name, but TERCE is a regional study for Latin America. This is only Latin American countries. And SACMEC, well, this is regional study in Africa. The World Bank has also been participating with international assessments, and they support, for example, PASEC, which is the analysis program of the Confirmation education systems, which is basically the African countries in where French is spoken, so French-speaking African countries. And they also support the PRIDI, which is the regional project on child development indicators. And well, you have a number of actors in this in the area of international large-scale assessments, and you have different kind of organizations. Something to point out probably is that the IEA is a research organization. This is an association of countries, and the representatives of each country could be sometimes the ministries of education, but also research agencies within the country. In the case of the OECD, this is rather an economic organization, and so on and so forth. So you can see that many different organizations, and for many different purposes, they are interested in participating in international large-scale assessments. But let's talk more in detail about the first two, the IEA and the OECD, which are the more famous, and they have better established studies in the field. So a good way to start, or to have a general overview of all international large-scale assessments, is a web page that is known as ILSA Gateway, which is the International Large-Scale Assessment Gateway. And this is a web page or website sponsored or promoted by the IEA. However, in this website you can find information about all international large-scale assessments in education. It's a very good place to start, because this is a single website when you can find information, all the information about all the studies. Things like fact sheets, like general characteristics of each of the studies in a standardized way, so you can compare and know what each of the studies is about. You have the frameworks. All these studies are based on some different notions or different theories, and of course they publish these frameworks, so they define or they conceptualize and they justify why they are measuring mathematics in one way or another, and why they are collecting the different background information I was talking about before. They also have information about the design of the studies, the sampling, how do they gather the data, what kind of procedures they have in place for translation and verification, what kind of quality control procedures they use. You can also find the results, the main publications of the results for each of these studies. You can find links to the data. So something important to say is that all the data from these studies is publicly available. So but sometimes it's not so easy to get to the page where you can download the data. And in this gateway, ILSA Gateway, they provide this service. They also have a collection of papers, reports, written with each of the different assessments. They have also links or files to different materials, documentation of the studies that can be useful for their analysis, and also information about the organizations or institutions that manage these studies. Okay, so the studies we are going to talk about today, or we're going to review in more detail, are sponsored by the IEA and by the OECD. These two major organizations, as I said before, are the International Association for the Evaluation of Educational Achievement and the Organization for Economic Cooperation and Development, known also as the OECD. They are different in nature and also different in the reasons why they participate in these studies or they organize these studies. Something to say or somewhere to start is by the mission statement of each of these organizations. In the case of the IEA, their mission statement is to carry out comparative research studies in education to develop and improve the capacity of education systems to engage in national strategies for educational monitoring and improvement. And in the case of the OECD, is to promote policies that will improve the economic and social well-being of people around the world. So as you can see, the IEA is an educational organization, the OECD is an economic organization, and therefore they have different objectives. If we can oversimplify it, we can say that the IEA is interested in educational achievement per se, and therefore they see the economic development as an input that can work or can influence educational achievement in countries, while the OECD looks at this same relationship from the completely opposite direction. So for example, for the OECD, if you read most of their studies or their reports, you will see that they look at education as an input for the economic development of countries. And with this fine distinction, you can extrapolate to many other things that you can read between lines in the reports of each of these organizations. So let's have a brief overview about TIMSS, PISA, and ICCS. And this is because they are the most recent studies of all the studies that I was talking about. The most recent ones are PISA, TIMSS, and ICCS. In TIMSS, as the name suggests, what they test is mathematics and science. In PISA, they test reading, mathematics, science, financial literacy, and problem solving in 2015. And ICCS is they test civic knowledge and attitudes and expected political or civil participation. TIMSS happens in 4th grade and 8th grade, and ICCS also in 8th grade. And in the case of PISA, the sample is not based on grade, but on the age of the students. So PISA is going to take a representative sample of 15 years old, ICCS of 8th graders, and TIMSS has 2 sections or 2 sub-studies. One is for 4th graders, a representative samples of 4th graders, and a representative sample of 8th graders. Why 15 years old? Why 8th grade, 4th or 8th grade in the case of TIMSS? Well, and basically is because different research suggests that in grade 4, children stop learning to read and start reading to learn. So by the time they're in 4th grade, they already read at a level that allows them to use this skill, the reading, to learn other things. And 8th grade, in the case of TIMSS and ICCS, or 15 years old, which is around the same, is because this is the end of the compulsory education in most education systems. In most education systems, when children reach the 8th grade or 15 years old, this is the end of compulsory education, and therefore in the following years, many of them are not going to be in the education system anymore, and many of them are going to be working actually. So how many countries participate in these studies? In the case of TIMSS, in the last round in 2015, we have 60 plus countries. In the case of PISA, 70 plus countries, and in the case of ICCS, 24 countries. Why do we say participation jurisdictions and not countries? Because they are not always countries. In most cases, when we talk about participants in these studies, we talk about countries, but in many cases, they can be also subsystems or education systems within the country. For example, in the case of Belgium, you have two education systems in the country, the Flemish system and the French system. And they claim that the education systems are different, they have different structures, different objectives, different curriculums, and therefore they prefer to be evaluated separately. In the case of the USA, many of the states, they decide to participate on their own, on the same basis, the basis that they are a whole education system. We have other benchmarking participants, as they are also called, like Dubai, instead of the UAE, or on top of the having a sample of the UAE, Dubai participates as a individual entity. And there are few examples, the city of Buenos Aires in Argentina and many others. So we also have the cycles, how often these studies happen. In the case of teens, it's every 4 years. In the case of PISA, every 3 years. In the case of ICCS, every 7 years. The last releases are TIMSS and PISA to 2015 and ICCS 2016. Well, this is the year where the data was collected, but the data varies, but normally released about 1 year after the data collection. The test booklets. We have 14 for TIMSS, 13 for PISA, and 7 booklets for ICCS. I'm going to talk about this in a bit more detail in the following slides, but what this means is that you have 14 different tests or exams. So, for example, in the case of TIMSS, when they test mathematics and science, it's not that all the children take the same exam. They take equivalent or similar exams, but the questions are actually different. So we have 14 different forms, booklets or tests for TIMSS, 13 for PISA, and 7 for ICCS. The testing time is for TIMSS 90 minutes, for PISA 120 minutes, and for ICCS 110 minutes. The questionnaires, so the background questionnaires, that the information that is collected together with the test, are from different actors. In the case of TIMSS, they collect information from the principals, school principals, from the teachers, and from the students. And in the case of PISA, they collect information from the principals, from the students, and as an optional feature, from the parents. Not in all countries, but many decide to collect information on the parents too. And for ICCS, information is collected from principals, teachers, and students as well. What is common across all these studies? First, the interest in reporting on group level characteristics rather than individual results. And this is something very important. Students cannot get a score, an individual score. You cannot get a score for each of the students that participate in the test. But what you get is the aggregated score. So what is for groups? It could be for groups of schools, it could be for boys, for girls, for private schools, for public schools, for the country, of course. But what you get is the average of a group of students. And why does it happen? Do you remember I told you that there are different exams, different tests. And what happens is that if you want to test all what a child at 8th grade should know about mathematics, the test would be very long. Actually, it has been calculated that if you give the full test with all the items that are needed to test what students should know about mathematics or science at a certain point, the student would need to sit for 10 hours in a row to answer these tests. So, because this is not possible, the student would get tired. They would waste, schools would waste too much time doing tests, etc., etc. It's just not practical. So what they do is that they take the full test and they divide it in different tests. So let's say they take each student actually answers. The full test would be I don't know, more than 200 questions, more than 200 items, but each student answers on average or around 30 items only. So basically you divide the full test in several subtests and give them to the students. What happens is that each student, or not each student, but many students take different questions. And then you use a statistical procedure to calculate an equivalent score. But the point is that one single student do not answer the whole test, and therefore you cannot give them a score to one single student. Okay, another thing that is common for these students for these studies is that the results are valid for the whole education system. So this is also very important. I said it before. I'm going to repeat it now. The sample, the information that you get, and therefore the results of the analysis are valid for the whole country. Well, in this, depending on the sample. If the sample is fourth graders, for all the fourth graders in a given country. So, for example, if we say that boys get on average 5 score points more than girls in mathematics, this is valid for all students at fourth grade in that country. Not only for the people who took the test, but for the whole country, for all the students in that belonging to this population. So as I was saying before, the domain is very broad. If you want to know what students should know about mathematics or science or reading when they finish compulsory education, the domain is very broad, and the testing time is limited because of time and because of budget. So therefore you have some challenges. You need to administer the test to a representative sample. You need to administer the items in a sensible design, so you cannot give 300 items to one student. And you need to summarize and compare performance on these items. So how are these challenges solved? We are going to see. They are solved doing modifications or having a specific design, and this is known as complex design. You have two parts of the study that you have to make complex in order to overcome the challenges we just described, and this is the sample design. So you have to have a complex sample design. This is a probabilistic stratified multi-stage sample design, and you need to take the sample design into account when you compute estimates or when you analyze the data. What does it mean, this complex sample design? Is that, for example, if you have a simple sample design, you would have the name of all the students. You could put them in a hat and then say you need 5,000 students, so you take 5,000 papers, and the students that got their names selected, they are the students who participate in the study. That would be a simple sample design. However, this would be very impractical. Can you imagine that you have 2 students in one school, 1 more student in another, 3 more in the next school, and so on and so forth? If the schools are in the cities, probably that wouldn't be much of a problem. But in many countries, in rural areas, for example, students are or schools are scattered across very big areas. So in some cases, it would take more than a day or two to get from one school to the other. And can you imagine what this would represent in terms of taking the tests, going to one school and then travel 2 days to go to another school and apply another 2 tests? That would be crazy, and that would be very time consuming and very expensive too in terms of the costs. So what do they do instead? They do a probabilistic stratified multi-stage sample design, which means that they take a sample of schools, and then within the schools they take a sample of students. And well, it's a bit more complex than that, but this is the idea. So because you have it in parts, that you have the sample in different stages, that is going to imply some specific and special statistical procedures that have to be carried out in order to compute correct estimates. Regarding the complex assessment design, it is known as the multiple matrix assessment design. And as I was saying, this is a design where nobody takes all items and no items are taken by all students. And this is what I was talking about. No, each student has a part of the exam, so therefore they are not evaluated in all the contents that the curriculum describes, but only on some. However, later on, a whole or a complete score is computed for each student using again specific special statistical procedures. So this is what I mean when I say that they need to take measurement uncertainty into account when computing these estimates. So these two these two concepts are important, and if you read reports or articles using large-scale assessments, you're gonna see them very often. They have a complex sample design and they have a complex assessment design. And we are going to talk now about these two things in a bit more detail. So what is a complex sample design? An example of a simple random sample is the next. In this picture, in this square, we have a sample of pixels. You know that all pictures are made of pixels. So if you take a sample of 500 pixels, a random sample of 500 pixels, this is what you would see. It's not much. You don't know what is in the picture when you do that. However, if you take 5,000 pixels, this is how it looks, which is already we can see some forms there. We can see that there is a face. And if we take a random sample a bit bigger, let's say 50,000 pixels, this is what we see. So as you can see, you have this sample. It's a simple random sample, and it's big enough for us to know what's in the picture. So we don't need to look at the whole picture, at all the pixels, to know what's in the picture. We can if we take a good sample, we will have a very good idea of what is in the picture. So, however, remember, this is a simple random sample design. What happened with a clustered sample or a multi-stage sample? This is what happened. Same amount of pixels, but on the left side of the screen, this is a simple sample. In the right side of the screen, you have a clustered sample. So what do you have in the clustered sample is that pixels are clustered. So you're taking the pixels that are next to each other. You take them in clusters, or you take them in chunks. And this is how you see. Even though you have the same number of pixels, when the sample is clustered, we cannot see that well what's in the picture. And therefore, again, you have to apply specific statistical procedures to come up with robust, correct estimates. And these special statistical procedures are known, well, we have different options, but one of the most popular is replicate weights, and the other one is multi-level models, which are techniques that are designed to overcome this limitation or that we have with the clustered samples. So, as I was saying before, many items this is regarding the complex assessment design. Now we talked about the complex sample design. Regarding the complex assessment design, we have that many items are needed to assess a domain as broadly defined as, for example, mathematics. At the same time, it is unreasonable to administer the whole item battery to each sampled student. So students are assigned subsets of the item pool, but what do we really want to know? As I said, students only take one part of the exam, but what do we really want to know? What are we interested in? The answer is, how would the student have performed on the test? Have we been able to administer all the items to all the students? So what would be the score? We know that the students only take one part of the test, but if they were able to take the whole test, what would be their score? And well, we don't know. we can only guess. We can have a scientifically informed guess, but it's still a guess. So the figure that you can see on the screen is a distribution curve. So if we are guessing, for example, the plausible value 1 or the PV1, let's say, is 500 points. So based on his or her characteristics, we are guessing, we are estimating that these students would have, a particular student would have 500 points. But the very same student with the very same characteristics could also have 550 points, or 600, or 400, or 350. We don't know. So that's why what we construct is a distribution of probability of the score that the student could have, and then take 5 random draws, which are the PV1, PV2, PV3. PV stands for plausible value or possible value. So we take 5 of them, because we don't know for sure what would have been his or her score if he had taken all the exam. So we take 5 possibilities and we combine them. We use them all every time we do any calculation for the assessment. So the complex sample design plus the complex assessment design is the two parts. No? The complex sample design, because we have a complex sample, we need to use sampling weights, and we need to use replicate weights or multivariate models, as I said before. And because you have plausible values, or because the students didn't take the whole test, we have to use these plausible values. And this is called complex assessment design. If you want to calculate the standard error for anything that contains or comes from a data set that has a complex sample design and a complex assessment design, you will need to use this formula. But please don't worry, you don't have to know this formula by heart, and you don't have to calculate the standard errors by hand. There's specialized software that can do that for you. So let's move on to some historic criticisms. They are not comprehensive, of course, but they can give you an idea of what are the criticisms that over the years have been posed to this assessment. First, some of the most cited advantages. Before going to the criticisms, let's have a quick look to the advantages. Some things that are good about these studies is that they are independent, unbiased in nature. So there are assessments that are independent and they are unbiased in nature. So because you have an organization as the IEA or the OECD, which in theory is not have no interest in favoring some countries over others, it's an impartial test. It's not the same to have the Ministry of Education of England evaluating the education system of England than having an international independent organization evaluating the education system of England. And therefore, it is expected that these studies are unbiased. So we also have, they allow, or one of their advantages is that they allow a better understanding of how a country fares through comparison with other nations. So sometimes we can if we evaluate one single education system, we know that we are doing good, but we don't know how good. And also it's useful to compare with other countries, because it's not only the score that the students are going to get in the exam. We can evaluate other things, like, for example, gaps. It is known that poor students achieve worse than well-off students. So, but how big is this gap? And in what countries the gap is greater or smaller? If we know these things, if we know that in some countries the gap is very small, we know that this country is compensating well for those socially disadvantaged students. And if we can identify a country that is doing it, and we can identify what exactly they are doing to get this result, well, probably other countries can benefit from it, and can adapt programs, policies, interventions that are being carried out with good success in some countries in their own context. They also expand our understanding of what is possible. In this case, we put high achieving nations and exemplars. And yeah, I mean, when you see same thing, we can have a gap related to socioeconomic status, but we can also have a gap related with gender. It's also well known that for science and mathematics, in most countries, boys do better than girls, but not in all. In some countries, there's no difference, and in some countries, there are even the girls the one who do better than boys in maths and science. So same thing. It's we are interested in understanding why there are so these differences. And these international large-scale assessments allow us to do that, which is the important thing. So related to the criticisms, they many people have objected the league tables ranking, saying that this is not useful for anything, and it's true. Having just a ranking of countries to do who do better than the other is not really very useful. What is useful is to know why. However, the why is not very often in the list of the priorities of the journalists, for example, no? Or the TV news. When they announce their results, they go straight to their ranking, and this is what is going to sell newspapers, but this is not what is going to help to improve education, for sure. Other people have criticized PISA in particular for promoting a free market agenda in education, a narrow, limited view of an adult education system, and a heavy bias towards OECD countries, but still recruiting many partner participants. So, PISA has been criticized for promoting a free market agenda in education. There's some evidence to suggest that PISA has been actively promoting accountability, a certain type of accountability by schools, and that this is not showing any good results anywhere, but still it is said that the OECD is promoting this agenda for their own reasons and their own interests. There's also heavy bias towards OECD countries, with countries, but they are still recruiting international partners, and some countries are stopping to participate in these studies. There are other criticisms that are more technical in nature, and for example, we have things related with the sampling. There was a very famous case in 2012 about Shanghai, which was ranked or appeared in the first or one of the first top 3 positions in the test in that cycle. But then there were some complaints or criticisms from other countries saying that in Shanghai the sample frame or the sample frame, the students were selected from a pool that contained only 79% of the 15 years old in the city. And they were saying that around 20% of the students were not considered in the sample. And they were not considered because in Shanghai there was a law that said that only the children who were born in Shanghai could attend the public schools in Shanghai. And therefore, the ones who are immigrants from other parts of China, they were not allowed to go to school there. However, they were attending some other schools, but they were not considered in the sample. It happens to be that these students who were not considered in the sample, they are very socially disadvantaged, and therefore there was a claim that the results for Shanghai were biased. And there are some other criticisms regarding that the achievement model used in PISA assumes homogeneous populations of examinees. That is, that the model assumes that the students in Peru, Italy, Singapore, USA, to give some examples, are equivalent, are the same. Furthermore, that the concepts that are measured in one country are equivalent to the concepts measured in other countries. And well, this is a clear criticism because you can say, for example, that one of the questions that are asked normally in all these studies is the level of education of the parents. And of course, the higher the level of education of the parents, the better the achievement of the children in the test. But at the same time, some people say, it makes sense, that having a university degree, to say something, is not the same in Germany than in Singapore, than in Thailand, than in Mexico. It means something different in terms of what you can do with a university degree in different places. And the same applies for other things. Like having a TB doesn't mean the same across different countries, and so on and so forth. So, to answer these criticisms, there are some statistical techniques that have been developed. In this case, this is called measurement invariance, that tell us how comparable these things that are measured are, because it's obvious, it's clear to say that it doesn't mean the same to have a university degree in different countries, but to what extent is that different? To what extent it is measuring something different? And well, there is this statistical technique, and there is a a set of studies, many by now, that are proposing different methods to measure or to carry analysis of measurement invariance. Another criticism in this area is the one that says that these studies are used for evidence-based policy, but sometimes also for policy-based evidence. That is to say that because the studies are so, they are large and they have so much information, it is easy to find, or it is possible to find, examples to support even contradictory claims. An example of this is class size. Many people say that class size is an important factor. Some people say that we have to have small classrooms with few students so they can receive enough attention and therefore learn better and achieve better in these tests. Some other people say that this is not true, that it doesn't really matter, or that is not very important. And using information from PISA, you can find examples, you can find data to support the claim that class size is important, but at the same time you can find evidence, data, to support that the class size is not important. So you're going to find some countries which are doing very good in terms of the results in the test, and where the size of the classrooms is very small, but you also can find some countries where the achievement is very high and the classrooms are very big in terms of the number of students. And same for different topics. Now, accountability is another one. Accountability is supposed to be good according to some people, to some theories, and bad according to other theories. Well, you can find evidence to support both, that is good, but also that it is bad. So that's why we have to be very careful when we analyze this data in order to have robust analysis, but also we have to be very careful when we read articles or papers coming from analysis of this data to make sure that they're considering all what has to be considered in order to have results that are robust, results that are unbiased. More about criticisms. We have another set of criticisms that are related with interpretation issues. And basically, in general terms, the criticism is that the data is being pushed to and beyond reasonable boundaries. And we have some quotations from the director of the OECD that says, for example, PISA shows what is possible in education. It takes away excuses from those who are complacent. Or success will go to those individuals, institutions, and countries which are swift to adapt and slow to complain and open to change. So, as you can see here, we could have, if I had been there with you, discussed these statements. But basically what you can see here is that when you say things like PISA shows what is possible and takes away excuses, you basically are saying that, or the bottom line message is that everyone can do well in education. You just need to make a bigger effort. You just need to stop complaining. You just need to change, which is in many cases, of course, not true. There are some other limitations that are not related to with education and that are affecting students. Just to put some extreme examples, there are students in many parts of the world that they have to walk for 3 or 4 hours to go to school every day, and they do so without having breakfast. So when a child is walking for 4 hours under the sun at 30 something degrees without having breakfast, you cannot really ask him or ask her to concentrate in the classroom, right? So and examples like that are many, and there are so many things related to the context that have to be taken into account when you do this kind of analysis, and that's why it's also not right from my point of view to come up with this kind of statements. If you want to see more about these criticisms or the original sources, there is a link in this slide, so just follow it. You will find some interesting information. So, what can we do with these studies? What are they for? Taking into account all the criticisms, all the strengths, all their characteristics, what can we do with them? Well, we can use them as socio-technical objects, which means it's clear, I think, by now that they are these studies are complex to analyze. You have to take into account many things in terms of the technicalities. Statistically speaking, you have to do a very specific kind of analysis. But so they are complex objects, but they also can be used and are used to characterize some parts of society, some parts of our education systems. So when we use them, we have to be able to talk about both things. On the one hand, the statistical technicalities, and on the other hand, the contextual factors that have to be taken into account in our models, in our analysis, in our interpretations, in order to make good use of them. We can use them also for a benchmarking function. I have said that before a few times, I think, by now, which is basically what I mean by that is that they provide comparable indicators on student performance and schooling practices across countries. So if we do it properly, if we do our analysis in the correct way, both technically and conceptually, then we can come up with indicators of good student performance. And as I was saying before, we can see which countries are those where there is no gender gap, or which countries are those who have been decreasing the gender gap over the years, or gaps related to socioeconomic status, or where in what countries socially disadvantaged students have higher chances of doing good at school. And then you can go and see what exactly they are doing, what kind of policies they have in place, what kind of practices they are using in their schools, what kind of training are receiving their teachers, what kind of support they receive from their families, etc., etc. And taking into account the context, you can come up with some ideas to be adapted or to inform the design of policies or programs in other countries in the world. They also have an analytic function, and this is they can suggest, it's related with the previous things. They can suggest hypotheses about relationships between student performance and factors that might influence performance. So if you have for example, a classic one, is the use of computers in the classroom something good, and under what conditions? So you have enough information here to answer this question. So you can do a bunch of correlations to see how, if the frequency in the use of computers is associated with a higher education achievement, and under what conditions, no? If what other things are happening at the same time that are making that this is good. In this specific example, you will see, if you run the analysis, a basic analysis, you will see that in some countries it's positive, in some countries it's negative, and then it starts to get interesting, because then you can, or you have to, or you can try different models using different variables, different control variables, postulate different kind of relationships until you find something that is useful, or you prove or not the hypothesis that you originally had. And also they can suggest hypotheses about areas where students have particular strengths or weaknesses. This is also very interesting. These studies provide information for mathematics, but not only for mathematics. They also provide information for different subdomains of mathematics. Let's say probability, geometry, statistics, etc. So you can see that in some countries, for example, probably in general, they are doing good in mathematics, but they are weak in probability. So then you can, or policymakers can go back and look at the curriculum. What are they learning? How are they learning? And try to improve these areas. The same for reading, and there are different subdomains of reading, which could be like identify specific explicit information, or to make inferences from what is read, etc., etc. And then there are different areas that where students may have or can have particular strengths or weaknesses, and then policymakers can take decisions based on that. A word of caution: so things that we have to take into account when we work with this data or read information, reports, articles that come from this data, is that there are surveys based on complex statistical principles. As I was saying, they are sociotechnical objects, and they have to be treated like that. We know what the students know and can do now, and the context in which this occurs. But this is a cross-sectional study. So this is, we know what happens now, but we don't know what happened before. An example for this is the number of books. The number of books at home is a very strong indicator, or it correlates or is associated strongly with student achievement. So the more the books the students have at home, the better they do in the test. Why? Well, there are different hypotheses. If we want to put it in simple terms, it is supposed that if there are many books at home, this is because the parents read a lot, and potentially they read a lot to the children, and the children have been growing in a climate where reading is something normal, and probably the students themselves read a lot, and that therefore they do better now. These students do better in school. But we know, and we ask the children, how many books are in your home now? But there might be many things that happened before or recently or after that are gonna modify this relationship. Now, for example, what happened if a child has 500 books at home, but they just got them as a gift or as an inheritance or something the week before the test was applied? So obviously the fact that they are now in the home, they have nothing to do with how the child grew up and the climate in the house, and probably the parents have never and will never read them, and the child, him or herself, is not going to read them either, so it doesn't make any sense. But nevertheless, if he replies that he has 500 books, he's got 500 books. And there are many things like that. The education of the parents is not the same to grow up with parents who both have a university degree than growing up with parents whose parents got the education, the university degree, probably at the time, or they're studying at the time that the student is in 4th grade, and so on and so forth. So we have to be careful with that, the temporality of the things that we are measuring. Well, this is related with the next point. No, we mostly have current background information, while learning effect or the effect might have occurred a while back. Um, yeah, same thing. You can ask a child the level of education of their parents, but probably the child doesn't live with the parents. So in which case it doesn't make any sense. No? Uh, the information is cross-sectional, that is in one point in time with repeated independent measures over time. So this is also to say that we know, we may say all the students who attend this school do well, but we don't know how they arrived to the school. Probably it could be that the school is doing very good, they are teaching them, they are improving, or it could be that the students were already good and the school is doing nothing. But we cannot know that because we have cross-sectional information. We don't know how they were performing before. They are not experiments. It's also, you will see in education when you read research, very often you have these randomized controlled trials. When you have a treatment and you have two groups, you apply the treatment to one group and do not apply it to the control group, and then they measure before the treatment and after the treatment, and then if there is a difference after the treatment, that means that the treatment was had an effect. If there is no difference, that means that the treatment had no effect. Well, this is not the case for these studies, and it's just to make the point clear. Therefore, because of all what I have said in this slide, we can make, or from analysis of these studies, you can make statements about correlations or associations, but not causation. So you cannot say that having more books causes higher achievement. You can say that students who have more books at home are normally, or are on average, obtaining higher achievement. You can say that the number of books at home is correlated or associated with a higher student achievement. But you cannot say that having books at home causes higher achievement. Otherwise, the only thing that you have to do is to give books to children, and automatically next year or next day you can test them and they are gonna have better achievement, which is obviously not true. And even worse, you cannot say that if you increase the achievement of students, the number of books at home is going to increase too. So if they have better grades in mathematics, they're going to appear magically more books in their homes. So this may sound stupid, but if you take other set of variables, it's sometimes the case that people make these kind of statements. So we have to be careful on how we interpret this data. Talking about the benchmarking function, I also wanted to give you some examples of the things that can be done. This is if you click on this slide, it will tell you to the website of the Center on International Education Benchmarking. And this center, what they do is that they take the results of these studies, and they take the top achievers, the top achieving countries, and they analyze what exactly is happening in those countries that makes this country perform well, or at least some of the causes. So they go, apart from the analysis that they could do with the data sets, they go and analyze policy documents, they go and analyze their curriculum, they go and analyze their policy developments or interventions to give some ideas to other countries who want to improve. For example, in the case of Canada, this feature in this website, they say Canada, due to a wide series of reforms in the past 2 decades, has emerged as an educational leader in international assessment rankings. Learn more, there's a link there, about how increased teacher autonomy and targeted policy directives change the way Canadian students learn. So they identify 2 things, no? Increased teacher autonomy and targeted policy directives. And they say that because of that, Canada has been this kind of changes in their policies over a few decades have made Canada improved over the time. And you have the same for different countries. And well, this is a good source of information that you could consult. This is another example, in this case, of the analytic function. This is from a book that I wrote with some colleagues last year. And well, the book is called Civics and Citizenship, Theoretical Models and Experiences in Latin America. And what we did here was to take a theory from an author who says this is a theory of how students get socially engaged, or how this can be measured. So this person says that in his theory, he said that first, in order to measure social engagement, you can do it from the electoral participation of the students, in this case the expected electoral participation. So they ask them whether they plan to participate politically when they are the legal age to do so, and also their participation in protests, illegal protests and legal protests. And then he said that this engagement can be measured from three main concepts. First, the analysis of evidence, the extent to which, or the frequency with which students analyze evidence, their capacity for empathy, and their sense of agency. So what we did in this paper, this analytical function, was, okay, there's this theory that has been published and discussed. Let's see if we can operationalize this theory with the data that we have in one of the data sets of these studies. So we took this ICCS, International Civic and Citizenship Study, that I was talking to you about, and we started analyzing. So we said, how can we measure analysis of evidence? Well, with civic knowledge, political discussion, and democratic values, the support for democratic values. How can we analyze the capacity for empathy of the students? Well, with their reactions towards physical aggression, gender equality, empathy as classmates, ethnic rights, and attitudes toward ethnic rights, and attitudes towards immigrant rights, and so on and so forth. So this is just an example of a structural equation model that we run in order to prove with it that this theory matches or can be operationalized with the data that we have, with empirical data, with real data, not only on theory, but also in practice. And this is another example in which we develop measures of students' attitudes towards gender equality, students' attitudes towards immigrants' equality, and students' attitudes towards ethnic equality. And then we had, as you can see here, all the countries that participated in the study and what is their average. So we can compare here in which countries the students have better attitudes towards gender equality, or immigrants equality, or equality for all ethnic groups, and in which countries they have worse attitudes. And of course, this is just an example, but then the next step, as I was saying before, is to try to find out why, what is happening in each of these countries for this to happen. No? Finally, some examples of the impact that this international large-scale assessment have had on policy. I mean, different kinds of impact have been documented in different countries. And for example, in Iceland and Japan, they increased teaching hours for mathematics and science instruction at the elementary level. So what happened in Iceland and Japan was that they were doing very good in the other subjects, but they were not doing very good in mathematics and science. What they found is that in their education systems, in their schools, children were having less teaching hours on these subjects. Therefore, they were learning less things, less topics. So they decided to increase the number of hours they were teaching mathematics and science, and they they improved their achievement. Now, whether this is something good or bad to do, this is a different discussion. I'm just documented here the impact that has had on policy. In Singapore, their targeted secondary analysis, their targeted secondary analysis led to the development of teaching resources to enhance cognitive and metacognitive skills. Same thing. Singapore is one of those countries who is always doing good in all these international assessments. However, they realized that one subdomain in which they were not doing so good was cognitive and metacognitive skills. So they trained and developed resources for teachers to strengthen this specific topic with their students. In Australia, some compensatory programs were introduced to address significant gender and socioeconomic effects on student achievement. So basically, they had huge gaps between boys and girls in mathematics, science, and reading, and they also have huge gaps between poor and rich students. And they, based on the analysis of these assessments, they developed compensatory programs to reverse this or to decrease or close these gaps. In Kenya, for example, they use these assessments to monitor the impact of free universal primary education, that the impact that this was having on quality. As you know, there are some countries like in Kenya where, there are countries in Europe where virtually all children go to primary school, but there are some other countries where only half of the children in the school age attend primary school, or different proportions. In Kenya was introduced the free universal primary education, which meant that many children who were not in the education system were at some point put into the education system. So basically all those students who normally were not in the education systems were, of course, very disadvantaged, very poor students, and suddenly if you put them in the education system, that is going to have an impact on the quality of the education. So they wanted to monitor this impact and also come up with analysis of what parts of the country the impact was greater or smaller, in order to do what to do, in order to know what to do. And another final example is in Slovenia. They had no curriculum for civic and citizenship education, and from this international study, they use it as a base to design their own civic and citizenship education study. If you want to know more details about these documented impacts or some others, you can check this International Large-Scale Assessments, the Handbook of International Large-Scale Assessments. The reference is there, and there's a chapter on Hans Wegemaker, who talks and develops this topic in detail. And that's everything.
Thank you very much for your attention.
From my side. If you have any questions, please do not hesitate to contact me, and I'll be happy to do my best to answer. Thank you very much for your attention, and again, I'm sorry that I couldn't be with you today.